classroom spokesman, Geometry-Parcon. So today, I will going to present to you the geometric 3D figures. So I have prepared here the four 3D figures. First, we have the triangular prism. So the triangular prism. And then the second is the cuboid. The third is the cube. And the last one is the pyramid. So I will going to present one by one, and I will going to give an example and the formulas in each of the figures. So fasten your seatbelt and get some learnings. So now let's begin first with the triangular prisms. So what is a triangular prism? In geometry, a triangular prism is a three-sided prism. So it is a polyhedron made of a triangular base. So here is our triangular base, this one and this one. So it can also be translated as the copy a three faces joining corresponding sides. So a right triangle prism has rectangular sides. So here rectangular sides, and otherwise it is oblique. So now I will going to present to you the formula of a triangular prism. So the triangular prism, so the formula, we have the volume equals to 1/2 times the base times the length and the height. So we have here the example. Calculate the volume of the triangular prism whose length is 15 inches and whose base is an equilateral triangle of side 6 inches. So when I say equilateral, it has the same size. So here the solution is, so for our area we have the equals to 6 inches, and for the length is 15 inches. So the formula for us to get the base area, or the area of the base, is 3a squared all over 4 is, and then we need to substitute the values. So square root of 3 times our a is 6. So 6 squared all over 4 is equals to 9 square root of 3 squared inches, or inches squared. So this would be our base area. So now to get the what is being asked, so the formula we are going to use for the volume is the volume of the given triangular prism equals to base area times length. So the value of our base area is 9 square root of 3, and the length is 15 inches. So 15 inches. So next step is to multiply. So when we're going to multiply this, the base area and the length, the result would be 135 square root of 3 cubic inches. So that will be the volume of our triangular prism. So for better understanding, I will give you another example. Okay, for another example, we have here the problem. Determine the volume of a triangular prism in which the triangle's base is 7 inches, its height is 5 inches, and the length of the prism is 10 inches. So let's assume here, so the base is 7. So we have here the base is 7 inches, the height is 5, and the length of the prism is 10. So 10. So what for the base, the first step we're going to do is to solve the base area. So the base area, the formula is base area equals to 1/2 times base times height. So next is we are going to substitute the value. So base area equals to 1/2 times our base is 7 inches times the height is 5 inches. So when we calculate it, the answer would be 35 all over 2 inches, and the unit would be squared, inches squared or squared inches. So we already find the area of our base. So next is the volume of our triangular prism. So the volume, the formula is volume equals to the base area times the length. So our base area is 35 all over 2 inches. 35 all over 2 times the, so our length here is, the length of our triangular prism is 10 inches. So times 10, and the answer would be what? Okay, the answer is 175 cubic inches. So this would be the unit of our what we get. So this is the final answer, 175 cubic inches. So now let's proceed to our second figure, which is the cuboid. So what is a cuboid? So in geometry, a cuboid is a hexahedron, a 6 faces solid. So it has 6 faces. Let's count first here. 1, 2, 3, 4, 5, and 6. So cuboid means like a cube. So we have here the cube. So it's just like a cube, but the shape is different. So in this sense, that by adjusting the length of the edges of the angles between edges and faces, so a cuboid can be transformed into a cube. So the cuboid, it has 8 faces. So it has 6 faces, a number of edges which is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the number of vertices, which is 8. So vertices. And now I will going to give you an example, the formulas and the example. So the formula, so volume is equal to length times base times height. So for example, find the volume of a cuboid of length 10 centimeter breadth 8 centimeter, and the height 4 centimeter. So for the solution, we have here the given. So given the length, which is 10 centimeter, our breadth is 8 centimeter, and the height is 4 centimeter. So the formula we are going to use to solve this problem is volume equals to length times weight times the breadth times the height or the base. So 10 times 8 times 4. So simple. You just need to multiply it, and then the answer would be 320 cubic centimeter. So that's simple. So for better understanding, I will give you another example. Okay, for the another example, we have here the problem. Calculate the lateral and total surface area of a cuboid of dimensions 12 centimeter times 7 centimeter times 5 centimeter. So given so our given 12 centimeter, which is the length, and 7 centimeter, which is our base, the base length, and the 5 centimeter, which is our height. So to find the lateral surface area, the formula we are going to use is lateral surface area equals 2 times height times length plus the base. So we put the given value, so substitute the given value. So 2 times the height, which is 5 centimeter, times the length 12 times plus addition rather plus the 7 centimeter. So 2 times 5 is equal to 10. 2 times 5 equals to 10. So 12 plus 7 is 19. So next step is to multiply both of these. So 10 times 19 is equal to 190 centimeter squared or squared centimeter. So this would be the value of our lateral surface area. So since we already find the value of our lateral surface area, now let's proceed to finding the value of our total surface area. So the formula would be TSA equals to 2 times the length times the base plus the base times height plus the height times the length. So bring down, substitute the given values. So bring down the constant. Then the value of our length is 12 centimeter. 12 plus the base, which is 7 centimeter. It is 12 times 7 rather. So plus the base, which is 7, times the 7 times the height, which is 5 centimeter, plus the 5 centimeter, the height, times the length, which is 12 centimeter. So now let us first solve inside the quantity. So 12 times 7 is 84. 7 times 5 is 35. Plus the 5 times 12 is 60. And then add all together. And then times 2. So the answer would be 358 squared centimeter or centimeter squared. 358 centimeter squared. So you can also try to solve it in your calculator if my answer is correct, or if it is wrong, so you can approach me so that I can change it. So now let's proceed to our third figure, which is the cube. So cube, it has a 6 faces. Let's count first. 1, 2, 3, 4, 5, and then the 6. So example of a cube, it can be a box or cartoon and a Rubik's Cube. So now let's find out the formulas in finding the volume or the area or diagonal of the cube. So we have here the formula of cube. So first we have the volume of cube. In finding the volume of cube, so we are going to use this formula, the A raised to the power of 3, or the area raised to the power of 3. And then second, we have here the total surface area, or TSA, of cube is equal to 6 area raised to the power of 2, or A squared. So, and then for lateral surface area of cube, we have 4A squared, and for finding the diagonal of cube, we have here the A square root of 3. So now, for our example, we have find the volume. So the volume, so when say volume, so this would be the formula we're going to use. So find the volume of a Rubik's Cube of length 4 inches. So 4 inches. So the length, or the length of the Rubik's Cube is 4 inches. Okay, now for the solution. So the length of the side of our cube is 4 inches. So the formula is volume equals to side times side times side, or the side cube or cubic side. So let us substitute the value. 4 times 4 times 4 is equal to 4 or the 4 raised to the power of 3. So when we calculate this 4 raised to the power of 3, or 4 times 4 times 4, the answer would be 64 cubic inches, or inches squared. So the volume of the Rubik's Cube is 64 cubic inches. So this is the final answer. So now I will give you another example. Okay, for another example, we have here the problem. The dimensions of a cube are 64 inches. So find its diagonal using the cube formula. So the solution is to find the diagonal of the cube. So the dimension of cube are length times width times the length is equals to L times width times equals to height is equals to 64 inches. So all over the length and width and height is 64 inches. So using the cube formula diagonal, which is a diagonal equals to a square root of 3. So let us put the values. So the values is, so the area would be 64 inches, square root of 3, and the answer is 110.848 inches. 110.848 inches. So this would be our final answer. Now let's proceed to our last figure, which is the pyramid, a tiny pyramid. So what is a pyramid? So a pyramid, it is a three-dimensional shape formed by joining the corners of a polygon to a central point or apex is named as a pyramid. So the slant height is the diagonal height from the center of one of the base edges to the apex, denoted by L, and height is the perpendicular distance from the apex to base. Height is denoted as H. So now I will going to give you the formula of the pyramid. So the pyramid, we have here three formulas. First, the lateral surface area, or LSA, equals to 1/2 times the P times the L, which is the slant height. The P is the perimeter. And then for the total surface area, we have here PSA equals to 1/2 times the perimeter times the slant height plus the base. And then for the last one, we have here the volume equals to 1/2 times base area times the height. So for example, find the volume of a regular square pyramid with base sides 10 cm and the altitude 18 cm. So for the solution, so the formula is we are going to find the volume. So we are going to use this formula. So solution, so V is equal to 1/3 base area times the height. So base area equals to 10 times 10. So equal to 100 cubic centimeter, squared centimeter rather. So volume equals to 1/3 times 100, which is our base area, times 18, which is the altitude, the value of altitude. So when we multiply, when we calculate it, the answer would be 600 centimeters squared, or square centimeter. So 1/3 times 100 times 18. So therefore, the volume of the regular square pyramid is 600 cubic centimeter. So, for better understanding, I will give you another example. Okay, for the last example, the problem here is find the lateral surface area of a regular pyramid with a square base. So, regular pyramid. It is the regular pyramid and the square base. So, if each edge of the base measures 16 inches and the altitude is 15 inches. So the solution, the perimeter of a base is 4 sides since it is square. So the perimeter is 4 because it is square. So, to find the perimeter, we are going to multiply 4 times 16. 4 times the base. And the answer would be 64 inches. 64 inches. And then the area of base is S squared, or the side squared. The area of base, so B equals to 16. So the area of base, rather 16. So 16 are the 16 squared, or the S squared. So the answer would be 16 times 16 is 256 squared inches. Squared inches. So to find the total surface area is equal to 1/2 times 64 times the 17 plus 200 plus the 256. So equals to 64 plus 17, and then times 1/2 is equals to 544. 544 plus the 256 is equal to 800 square inches. So this will be the value of our total surface area. So we already find the volume, so, and then we also have the total surface area. So that's all for the pyramid. So I want you to remember what I have present today. So first I have the triangular prism, and then the cuboid, and then the cube, and the pyramid. So remember all those formulas because you can use it in the future. So I hope you learn from the lecture I have present today, and do remember it, so because you can also use it in real life situation. So that's all for today's lecture. Thank you and God bless.